Hello, I'm Martin Cherney from XBIM, and this is the second part of the video for anybody interested in automated validation of information requirements. In first part, we had a look at ISO standards to use to think about information requirements and how to capture them. Today, we'll have a look at details of Information Delivery Specification and continuous quality control based on the Information Delivery Specification, IDS. So IDS is part of a family of standards. Here you can see buildingSMART Data Dictionary, BSDD. That can be used to get terms and definitions. It contains a list of recommended properties, and it can also be used as a reference source of classifications. You can watch the first part of this video to see how it fits together to form the actual information requirements. When IDS is used to actually capture the information requirements, it should be used to inform the content of BIM models. That is where IFC gets in play. It stands for Industry Foundation Classes. It is ISO standard used to describe the buildings, to capture the data about the buildings themselves. Now, once the data is created and the validation is run using IDS, it can create BCF, BIM collaboration format. That would contain all the issues and the issue management to improve the quality of the IFC. So it can be used as part of the feedback loop for iterative improvements of the BIM models. As mentioned in the previous part of this video, IDS has been developed by buildingSMART. It was developed relatively quickly compared with standard procedures at ISO and SAN. It was designed to be free, so the documentation is available at GitHub. It uses standardized approach to model checking. It also contains a set of abstract tests to make sure that when these requirements are described in IDS, and if two systems are used to run these validation checks, they should give you the same results. It is also lightweight, which as a developer I can confirm is relatively easy to understand. It's easy to create. There are many tools being developed right now to help you to actually translate your plain language questions into these well-structured requirements which can actually be processed with computers. IDS has two concepts. One is selection, another is validation. In other words, if you want to validate certain requirements, say for a door, you first need to select it. You first want to define the subject, that is the selection. So the selection might be every door where the width is more than 500 millimeters. And then the validation might say that this door should have a certain property of certain value. So for both selection and validation, you can use one of these six, they call them facets, these six types of queries. So first is the entity type, that is a door, a window, a floor. You can use attributes. These are things like name or description. You can use classification, which is independent concept in IFC. You can use properties, both for selection again and for validation. You can use material to select and validate, and you can use parts type of query, which is used for conceptual relations like the door is part of the wall or the chair is actually in a space, and that kind of queries. So as I said, this is the structure of IDS. So the applicability is actually your selection part. And then requirements are things you actually want to verify. When we take these things all together, so we have IDS, which is defined to be mission readable. It is defined by developers for developers effectively. And we have IFC, which also is the standard for the data. With IFC, computers actually understand the substance of the building. With CAD, computers didn't know what things were, right? Just bunch of lines, colors, dashes, etc. But with IFC, computers actually know this is a wall, this is a window. Now IDS is the same. It says for a window, I want certain requirements to be fulfilled. So when you take these two things together, we can actually run a rigorous and reliable validation. Now, when we take that a step further, we thought, well, it would be interesting to actually use the same approach like we use every day in software development and create continuous integration with IDS. What that means. In software, it's normal that developers would write a code. When that code is uploaded to server, that would detect the change. It would automatically build the code. It would automatically test it. It would automatically deploy it, right? And it would, as it goes through, it may be sending notifications. It may ask for approvals, etc. That is 100% automated. It's user definable at the same time. It's repeatable. So if you make the same change twice, it will have exactly the same behavior and is independent. So once it's defined and it fails, it's like an independent arbiter who says this is just not correct. And it's not your colleague. You can't just trick him. You can't buy him a beer, right? And with IDS and IFC, we can actually do the same. We can put IFC file in the cloud and using our platform FlexFlow, we can actually test the model and we can publish the results. We can create BCF results. We can even publish to our communication environment where people can actually act on these issues. And this is how we tried it, right? So first of all, last time in first part of the video, I explained why it is a very bad idea to use Excel to describe your requirements. Now we found out that there is another tool which is not far from Excel, so it's still tabular, but it actually guarantees the data integrity and you can use it to nicely model the data structure. So we used a third-party tool called Airtable. That is connected to our automated service, so we can actually read from there, get the IDS rules, run the validation engine, and get the results with nice overview like you can see there. We would also create BCF results, so any issue is captured there. And as part of this process, we also automatically publish it to our communication application, just comms, where people can actually share 3D views. They can have a conversation around the building. They can have a conversation around these issues, and they will see every single failed rule and every single failed element. So they can actually inspect them either by type or one by one. If you think it's interesting, get in touch. We are very happy to show it to anybody really. And I think there is great value in that to actually run these validations automatically.